Hello everyone, welcome to my channel Learnitor. So today we are going to solve the Leetcode problem. So we can select the Leetcode today's daily challenge from here. So we are going to solve that problem. So every day Leetcode is trying to give you one problem and you can solve that problem. So it is a medium type of problem. It means has number 198 house robber problem. So first thing I will do is start the timer so that we can find out in what time I have completed my to solve this problem. So you can do also these things because you get to know about means in what time you are trying complete that problem, because in interviews you need to solve the problem in 20 or 30 minutes. Let's go to the question today. So you are a professional robber planning to rob houses along a street. So each house has a certain amount of money strat. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. So this is the important thing. You have to rob the houses and you can't rob the two adjacent houses. Okay. So they have given an integer array nums representing amount of money of each house. We have to find out the maximum amount of money you can rob tonight. So whenever there is a maximum term, so it tends to the dynamic programming. Okay, so I hope this will be one of the dynamic programming problem. So let's take this example and how we can solve that. Let's try to do that. And I just opened the whiteboard. So let's say, so these are the houses, and let's say if you want to rob uh, this house, one house, then you can't take the 2 1, then you have to take 3, and then you can't take 1. So in this case we will get the output as a 4. So let's say if I take the 1, and if I not take this one, not take this one, and if I take the 2 1, so the output will be 2, because we can't take the adjacent houses. Let's say if I have not take this one, I have take this one, so I can't take this one because this is the neighboring house, and this is the one, so that will be gives us output as a 3, and out of which we are getting the 4 as the maximum output for this. Let's take second example for more clarity to clear picture of this problem. So let's take, if I have taken 2 as a problem first, then I can't take 7 in that case, so I can take 9. I can't take 3, and in that case I can take 1. So in that case 2 9 1, that will be the answer, which will be the 12. Okay, so let's say if I not take the 2, then I can take the 7, then I can't take 9, if then I can take the 3 1 and not 1. So that way gives us the output as a 10. Okay, so you are saying like let's say if I take the 2, if I not take 7, if I not take 9, and if I take the 3, and if I not take 1, so this will be the one more answer, which gives us the output as a 5. So why you are thinking like means we, if we take 2, we not take 7, not take 9, because it will be anything. So some of the uh, unit test means the alternate case. So previously what we have did, like alternate we have choose like 2 9 1. Okay, and this case also we have alternate choose, so alternate will be not the answer here. You can choose anything and then it will means any a number which is greater, then also we can consider over here. Let's say for example I have considered, so this is not a 3, let's, this is the 100. Okay, and this is the 1 over here. Okay, so let's take, if I take these 2, and then if I can't take this one, and if I take 9, then this 1, then it will give me 11 and 12 as the output, but we have the 100. Okay, so if I select 1 and this 100, then we will get the 101 as the output. So in that case we have taken this and this, and all other things are we are not taking. Okay, and it satisfies our condition. So again, this is not the maximum output. So let's say if I take the 2, if I not take this one, not take 9 and take 100, and so this is the neighbor one, so I can't take this. So 2 and 100, which is the 101, that will be the correct output for this test case. So I hope you can understand the problem set for this. So that's why here we need to use the dynamic programming and not the greedy algorithm. So let's solve this dynamic programming. How we can solve? So let's check how we can do this. So in dynamic programming, like we can first write the recursion for this. So there is the index for the each of the case, and let's say how we can write the recursive case for that. Okay. So let's say if I select one thing, okay, let's say something I have selected, current item. Okay. So what it will do, like it can't select its neighboring item. Let's say I'm going through from the end of the index. So this will be can't index minus one. It should be index minus two. If you have not selected something, so here if you can check this diagram, there is a question of selecting and not selecting. Here we have selected 2, not selected this one, not selected this 9, and selected the 100. So each of the steps we have to find out whether we can select or not select, and according to that we have to write our code. So for the not selected case, so for selected one is like nums of index plus function, and which will goes to the index minus 2. And in the not selected case, I will directly go to the index minus 1. And at that point also, we can check whether that particular index we need to take or not. So what will be the base case of this? So we can go to the less than 0, or index will be greater exactly equal to 1 also, or index exactly equal to 0th index. So both are will be the base cases over here. So in that case, we will just return the 0, and if we have the index as 0, then we will just return whatever the nums of index over here. So these are the two base cases we can find, because at the index exactly equal to 0, he have to select that particular index 0. Okay, or this also can not be the means base case. If we select this only base case, that is also enough. So let's write the code for this one. So first we need to the size of the our nums array. So here I am selecting the C++, but you can know the pseudocode of this, so you can write it in your own code, own language like Python or Java. So here I'm passing nums with its index. So what will be the index? Like n minus 1. I'm passing. It will return integer as util. Nums we will take as it is, and we have the integer index. So if that index is going less than 0, we have to return that 0. Okay, this will be the base case. And what will be the recursive case is like integer selected. In that case, so we have selected, so it will be, we can pick the nums of, and we are going recursively with the function of that. So it will go to the index minus 2, not the index minus 1, because index minus 1 will be its neighbor. So in the case of not selected, this we can directly call the index of minus 1. I hope this will return, we have to return the maximum of from selected and not selected. This is our recursive code for the program, and let's check whether it is running or not. So it is checking. So there are initial two test cases will be there. Yeah, we have to, it's something wrong, we have missed the nums over here. Oh, this is the silly mistake I did. Oh yeah, so both of the cases are giving me the result. If I submit this code, then it may give the TLE, because the recursion has the major time complexity over here, because in each of the cases we have the two ways, like select and not select. So the time complexity will be like almost n square, and there will be like again the time complexity for this one. So as expected, it is giving the TLE. So let's optimize this one. So to optimize this one, we can do like, we can select, we can pick one DP. Okay, and this DP what we can do like n plus 1 the size of minus 1. Okay, I take an n plus 1 for the index of less than zero's value. Okay, and I'm going to share this TP in the code, and similarly over here. Make note that we have to use here the reference because it will impact the time complexity over here. So what we can do, like if we have the DP value as index plus 1 is not equal to minus 1, then we can return directly DP of index plus 1. Okay, and we have to store this value at somewhere, so we have to store it in DP of index plus 1. Okay, so I'll just run this code. We will check whether it will work, but it will not work because we have not passed DP over here and also over here, and same error they have given. So I will again run this code, and yeah, it solves the issue, and whatever the test case giving me the DLE, that is giving me successful result. So let's submit. So this is not also optimized code. So over here we are also going to the so time complexity will be order of n because we are checking only number of n over here, but still we are going the recursive way. So in that case that whole n square tree we are visiting, so auxiliary space it takes like n square n rest 2, that is n square. So again we can optimize, but meanwhile we can submit this code and just check whether it is giving the exact result or not. Yeah, it is saying completion and it gives the 0 millisecond 100% of that, but still we can optimize this one. So we will check, let's say how we can optimize this one. Let's initialize this with the 0. These are the steps to, yeah, and we can copy whatever present over here or here, and then we can do like opposite of that, like integer I from the 0, I will be less than equal to n I plus plus. Oh, I have forget this thing. We have to line, and similarly it will do like dp of x minus 2. This will give, so wherever we are calling we have to just change it to the dp. Okay, so we have to pick like that, but there is a one catch over here. We have to start from the one. So nums of will be like index minus 1, and dp has the like index for that. So dp of index minus 2 is present over here, but our I is starting from the 1, so we have to do like dp of 1 will be the 0th value of that code. Okay, so we can initialize this thing because at the 0th index the output will be that particular one. So in this case means when it comes to the 1 we have to return 1 because this is also one of the base case which we have discussed over here. So I have did that, and now we can check, and we have to return dp of n as the output of this code. Let's check whether we get the output or not. Let's run this program and check whether it will give us the output or not. Okay, I have used the I. Change it to the index. So this silly mistake we can do. We have to review, but I am not currently reviewed. But this is the best way. Like you have to review your code so that it will means work as expected. So all the test cases are passing. So we can submit once again and check whether it is work or not. It is again passed. This is 0 millisecond and memory with 9.67% of users. Okay, so yeah, again we can optimize this one, and how we can optimize, that is the question. So we have like dpo of index minus 2, dpo of index minus 1 over here, and dpo of index. So we can take three variables and we can give the output as expected. Let's remove this code because this is not currently required. So let's say I have something current value. I can initialize it with 0. We have something like previous, which is also 0, and previous of 1, also 0. So dp of index minus 2, we will consider it as a previous of 1. Dp of index minus 1, we will consider it as a previous, and we can consider this as the current. Okay, so this will be the current, this will be the previous, and this will be the previous one. Okay, but one thing we are missing, like we have to initialize again that values like this. We have to initialize previous one with previous, previous with current, and at the end we have to return the current one. So current will give the our current values, and this is also not required. Now I got the issue over here. So previous we have initialized with the dp of is num sub 0, right? That thing we have not did over here, which is the base case I just removed. So that was the issue, and I hope this will run. So yes, then it will work because it is not giving going inside of that. So if it has a 0, so it will we have initialized with the previous, so that will work. Yeah, so this is the small issue I got. Yeah, it is giving bits 45 seconds, but this is the way some of the problem in the Leetcode, because sometimes it gives 100%, sometimes it gives 25%. So Leetcode, if you are watching my video, then please do the needful for this thing. And thank you guys, thank you for visiting my this video and looking into it. If you have questions, then put it in the comments. If you want to discuss with me, then you can check my website learnitor.com. Thank you for your time. Have a nice day.